I want you to try a little experiment with me. It's just a mental exercise.
Okay, I'm in.
Picture your morning routine. You wake up, you hit the light switch, you stumble into the kitchen, press a button on the coffee maker.
Plug in the phone.
You plug in your phone, maybe turn on the news. It's all just automatic,
That-
right? It feels like magic.
It feels like magic until you smell burning plastic.
Right. And that is exactly the moment the magic dies. But here's the reality. There is this massive, complex system running behind your drywall, a silent conductor that makes our modern life possible.
And we completely ignore it.
We treat it with total indifference, frankly, until it stops working.
Or, and this is the important part, until it becomes dangerous. That's the catch. It's invisible, so we forget the actual physics happening inside the walls are, well, pretty intense.
Precisely. So today we are doing a deep dive into the, let's call it the nervous system of your home and your business for that matter. We're digging into a whole stack of insights and technical guides that were provided by AT Electric LLC. They're based out of Mansfield, Texas.
Oh, that's interesting. So they're dealing with high heat, humidity,
Shifting soil, all these conditions that really, really stress test an electrical system.
which makes their data really valuable for this conversation. You know, we aren't just talking about changing a light bulb here.
Not at all.
This is about high-stakes engineering, modernizing infrastructure, and to be honest, the difference between a safe home and a potential fire hazard.
So here's our mission for this deep dive. We're going to help you diagnose the health of your home's brain. We're also going to debunk the biggest myth about surge protection. And I was shocked by this one. I really was.
That's a big one.
And we're going to look at why lighting is actually a form of psychological command and control.
I love that framing. It turns, you know, home improvement into a strategy section.
It really does. So let's start at the source. The control center. In the industry, they call it the panel or the breaker box.
Right. AT Electric, though, they call it the heart of the property in their guides.
They do, which is great, but I kind of like your idea of the brain.
Well, it's the decision maker, right? It decides where the energy goes and, crucially, when to cut it off. And the core problem we're seeing in the source material is what I like to call the time travel paradox.
Okay, explain that. Are we going back to the future here?
Huh? In a way. I mean, think about the year 1980. What was plugged into a standard living room?
A tube TV. A lamp, maybe. A
Yeah.
vacuum cleaner once a week.
Exactly. The electrical load was minimal. Now, fast forward to today.
Oh, boy.
You've got smart speakers, a 65-inch OLED TV, a gaming console, a router, a mesh Wi-Fi system, maybe a high-efficiency HVAC running constantly.
And that's just one room. You look in the garage, you might have an electric vehicle charger pulling a massive current.
Right. So we're trying to run a 2025 lifestyle on 1980s logic.
Worse than that.
It is. We're trying to push a fire hose of data and power through what is essentially a drinking straw.
Yeah.
The sources from AT Electric are very, very clear on this.
What do they say?
If your panel is rated for 100 amps, which was the standard a few decades ago, it is likely mathematically impossible for it to keep up with a modern load without straining.
So what does straining actually look like? Because my lights turn on, I don't see the strain.
You might not see it, but the system feels it. The most obvious sign is the breaker trip. But let's actually unpack what that trip is,
Okay,
because people really misunderstand it. They just think it's a nuisance. Oh, the power went out. Let me just go flip the switch.
I'm definitely guilty of that. I just flip it back and keep going. It feels like, rebooting a router.
But it's not a reboot. It's a safety save.
Yeah.
A breaker is a thermal device.
Thermal. How does that work?
Inside, there's often a bimetallic strip, two different metals bonded together. As electricity flows through, it generates heat. If too much current flows, if you overload it, that strip actually bends.
Because the metals expand at different rates.
Exactly. When it bends far enough, it physically snaps the circuit open.
So it's basically on a suicide mission.
Precisely. It sacrifices the connection to save your wires from melting inside the walls.
Wow. Okay, so when I flip it back immediately without turning anything off, I'm essentially telling the system, hey, I don't care that you're overheating, just keep working.
You've got it. That's what you're doing. If it happens once, maybe it was a fluke. But if it's happening every time you run the microwave and the hairdryer at the same time,
Uh-oh.
that is your panel screaming for help. That is a capacity issue, plain and simple.
The sources also mention sensory warnings, which I have to say sounds like a horror movie trope.
It's the stuff you really don't want to experience. Flickering lights, that's often a voltage drop. But the big one is smell.
Smell.
If you smell burning plastic or, and this is a weird one, fish, Melting insulation often smells like fish.
No way.
Yeah, if you smell that near your panel, that is a red alert. That implies arcing, where electricity is jumping across gaps or just straight up melting wires.
And that leads to the other red flag they mentioned, which is purely behavioral, the power strip chain.
Ah, the daisy chain. This is my biggest pet peeve.
Yes, I have seen photos of this. A power strip plugged into an extension cord, plugged into another power strip. I've definitely done it behind my TV console.
Oh, you're killing me. That is the electrical equivalent of holding a hand grenade.
It's that bad.
It is. If you are relying on power strips for daily use, not for a lamp, but to run your office or your kitchen appliances, your home's infrastructure is obsolete. You are bypassing the safety mechanisms and creating these little heat points that the breakers might not even detect until it's way too late.
So let's talk solutions, because upgrading the panel sounds incredibly expensive, like I need to take out a second mortgage.
It's an investment, for sure. AT Electric quotes a range of roughly $1,500 to $4,000.
That's a huge range.
It is, but it really depends on the power you need. A basic upgrade is on the lower end. But if you need 200 amps or even 400 amps because you have a pool, a hot tub, and 2 Teslas.
400 amps sounds like an industrial plant.
It's becoming more common for large luxury homes. But look at the ROI, the return on investment. It's not just about stopping the flickering lights. The sources point out that a modern panel is a massive selling point in real estate.
Oh, I can see that. If I walk into a house and see a rusted old fuse box with those glass fuses, I'm mentally deducting 10 grand from my offer.
Exactly. It just screams deferred maintenance. Plus, new panels often include something called arc fault circuit interrupters, or AFCIs.
What do they do?
They're way more sensitive to the specific types of electrical faults that actually start fires. So you're buying safety and resale value in one package.
And what about the time? Am I living in the dark for a week while this happens?
No, and that's a common fear. It's typically a one-day job, 4 to 8 hours.
That's it.
They do an inspection, shut off the main power, swap out the panel, test everything, and turn it back on. It's surgical.
Okay, so that covers the brain. But I want to move to the immune system, because there's a threat mentioned in the guides that feels completely invisible to me. Surge protection.
This is, hands down, the most misunderstood topic in residential electricity.
I bet I know why. It's because we all think we're protected, right? I have that little $15 strip from the grocery store plugged into my computer. It says surge protector right on the box. Am I safe?
You are safe from, maybe, a tiny static shock. But you are not safe from a grid event.
Okay.
And here's the nuance the sources really hammer home. A surge isn't just lightning. Everyone thinks, oh, if lightning strikes my house, I'm done for anyway.
Right. That's exactly what I think.
But get this, 80% of power surges are actually internal.
Wait, what? Coming from inside the house?
Yes. Every single time your AC compressor kicks on, or your fridge motor cycles, or your laser printer warms up, it creates a mini spike in the voltage. It disturbs the flow. And over time, these microsurges degrade the sensitive chips in your other devices. It's like death by 1,000 cuts for your electronics.
I never thought about my own switch attacking my TV.
That's pretty much what's happening. And then, of course, you have the big external surges grid switching, blown transformers down the street. That little strip you have. It has a tiny component inside called an MOV, a metal oxide varistor.
An MOV.
Think of it like a sponge. It absorbs the excess energy, but just like a sponge, it gets full. Or it just degrades. And eventually it stops working, usually without telling you.
So it's a placebo after a while.
Correct. The real solution that AT Electric advocates for is whole house surge protection. This isn't a strip you plug in.
What is it then?
This is a device that's installed physically at the panel. It acts like a bouncer at the front door of a club. It stops the spike before it gets into your home's wiring and travels to all your outlets.
That seems crucial now because all our appliances are basically computers.
That's the key. 20 years ago, a washing machine was a motor and a timer. You could fix it with a wrench.
Yeah.
Now, it has a motherboard. Your oven has a microchip. If a surge hits, you aren't repairing a knob. You're replacing a $400 computer board. The surge protector is just insurance for the $10,000 of appliances sitting in your kitchen.
That makes a ton of sense. It protects the investment. Now, there's another layer of prevention here. Inspections. The source material uses a medical analogy I liked. The checkup.
It's a perfect analogy. You don't wait for a heart attack to check your blood pressure. But with our homes, we tend to just run them until they break.
So what is an inspector actually looking for that I can't see? I mean, wires are just wires, right?
Not exactly. They're looking for the effects of time and physics. specifically thermal expansion.
Okay, break that down for us.
So you live in Texas, or really anywhere with seasons. Wires heat up when you use them, and they cool down when you don't. Copper and aluminum, they expand and contract at different rates.
I'm with you.
Over 10 or 20 years, that microscopic movement can loosen the screws holding the wires in place at the terminals.
Okay, I can see that.
And a loose connection increases electrical resistance. Resistance creates heat, and heat creates fire. It is literally physics working against you over time.
So the house is slowly unscrewing itself from the inside.
Slowly and silently. An inspection isn't just looking, it's tightening everything down. It's checking for grounding issues. AT Electric says if your home is over 20 years old, you are in the danger zone if you haven't had a professional look. It's really just peace of mind.
That is slightly terrifying, but also really good to know. Okay, let's pivot. We've done the safety, the heavy engineering, the invisible threats. Now I want to talk about the face of the home, the aesthetics, because the source material has this great line about how a flickering light or a clicking fan blade ruins the vibe faster than a Texas humidity spike.
It's evocative, isn't it? But it's so true. Lighting sits right at the intersection of engineering and psychology.
Let's start with the engineering side. Ceiling fans and chandeliers, I've always thought of these as just decor. You buy it, you hang it up. Why do the sources treat this like building a bridge?
Because gravity is unforgiving. And because so many DIY projects fail dangerously right here, the source makes a big distinction between a static load and a dynamic load.
What's the difference?
A chandelier is a static load. It's heavy, maybe 50 pounds of crystal, but it just hangs there. You need a box rated for that weight so it doesn't just rip out of the drywall.
Okay.
A fan, though, is a dynamic load. It vibrates. It has torque. It's trying to twist itself off the ceiling every single time you turn it on.
Oh, I see. It's actually moving.
Right. And if you screw a fan into a standard plastic light box, which happens all the time in DIY jobs, eventually the vibration will fatigue the plastic or the screws.
And then?
And then you get what the source calls 10 pounds of metal crashing onto your dining room table.
Yeah, that's a dinner party killer. Pass the potatoes and watch out for the falling motor.
It's structural work. You need fan-rated bracing bars that dig into the joists. It's not just hanging a light. It's anchoring a machine to your ceiling.
And then there's the visual side. They talk a lot about visual noise. I love this term.
This is for the minimalists out there. Visual noise is clutter. Floor lamps, cords running everywhere, bulky track lighting from the 90s that looks like a robot spider on your ceiling.
It just shrinks the room.
Totally. And the solution they propose is recessed lighting.
Canna lights.
Exactly. You put the hardware inside the ceiling. It makes the room feel taller, cleaner. But, and here's the technical nugget that I think listeners really need to hear, you have to get the color temperature right.
Is this the whole warm versus cool light thing?
Precisely. It's measured in Kelvin. In the old days, LEDs had that awful clinical blue tint. It felt like an interrogation room.
Or a dentist's office.
Right. That's usually around 5,000 Kelvin. The sources emphasize that for a living space, you really want 2700K or maybe 3000K. It mimics that warm incandescent glow we all love.
So if you put 5000K daylight bulbs in your living room,
You'll look like you're standing in a gas station.
Yeah.
It kills the atmosphere immediately.
That is a great tip. Check the Kelvin reading on the box. Now, moving outdoors, the guides get almost poetic here. They call the sunset the countdown.
A Texas sunset is a masterpiece, but it is also a countdown. I love that phrasing.
It implies that once the sun is gone, the entire nature of your property changes completely.
It creates voids, and shadow is where security fails. This brings us to the concept of command and control.
It sounds so military.
It is, in a way, if you rely on those cheap solar stakes from the big box store.
The ones that glow like dying fireflies.
You have surrendered control of your perimeter. They provide no real light.
They're basically just decoration for the ants.
Pretty much. Professional landscape lighting does two things. It highlights the architecture, which makes the home look imposed and occupied, and it eliminates the dark pockets where someone or something could hide.
So it's security disguised as beauty.
Precisely. A well-lit home tells a potential intruder, this homeowner pays attention. Everything here works. There are no hiding spots. It's a psychological deterrent just as much as a physical one.
I want to briefly touch on the commercial side before we wrap up because AT Electric does a lot of work with businesses in Mansfield. The stakes there seem even higher.
Oh, for sure. Money is on the line. They call it the winter liability. Think about it. In winter, it can be dark by 5:30 p.m.
Right.
If your business is open until 9, you are operating half your day in the dark.
And if your parking lot lights are flickering or dim.
Two things happen. One, you have a literal liability issue. Slips, trips, falls, car break-ins. If the lighting is found to be negligent, that lawsuit lands on you.
And the second thing?
It's the open versus closed signal.
Right. I've driven past places that I thought were closed just because the signage was dim or a few bulbs were out.
It's just bad branding. The shift from those old buzzing orange streetlights, sodium vapor, to crisp, bright LEDs isn't just about saving electricity.
It's about signaling health.
Exactly. A brightly lit business looks successful. A dim one looks like it's struggling.
It's amazing how much we subconsciously judge a place by its lumens.
We do. We are visual creatures. We're always gravitate toward the light.
So we've covered a massive journey here. We went from the thermal strip inside a breaker box to the microchips in your fridge to the Kelvin rating of your living room.
All the way to the security of your parking lot, from the invisible mechanics to the highly visible aesthetics.
If we had to distill all this down for the listener, what is the one thing they really need to take away from this?
I'd say it's this. Stop treating your electrical system as a static background feature. It is a dynamic machine that ages, that degrades, and that needs maintenance.
And if you're hearing clicking or smelling burning or resetting breakers,
do not DIY it.
Right. Licensed and insured. That was a phrase that appeared over and over in the AT Electric documents.
Because the margin for error is zero.
Yeah.
You mess up a paint job, it looks ugly. You mess up a wire nut, you could lose the entire house.
That really puts it in perspective. I want to leave the listener with one final thought. We spend thousands on granite countertops, on 4K TVs, on nice landscaping, all these things we can see, but we neglect the silent conductor inside the walls because it's invisible. So ask yourself, if your house could talk, what would it say? Would it tell you it's barely hanging on?
That is the question worth asking.
A huge thank you to AT Electric LLC in Mansfield for providing the deep technical insights for this deep dive. They really helped us shine a light, pun absolutely intended, on how this all works.
It was an illuminating discussion. Stay safe out there.
Go check your breaker panel, but maybe don't touch it, and we will catch you on the next deep dive.